Good morning, everyone. I'm Kamal from CICB, and today I'm going to present on the topic function overloading. Is my screen visible?
Yeah, it is visible, Sai. You can start.
Thank you, sir. Yeah. So I'm the team lead of batch number 1, and today I am going to present on the topic function overloading in C++. So before we jump right into the topic, there are a couple of prerequisites that will help you to understand the topic more clearly. We'll discuss those. So the first thing you need to understand is the C++ basics. The C++ basics include syntax, data types, and object-oriented features. So you might be already familiar with the syntax, that is the cout functions, the cin functions, the return statements, etc. And coming to the data types in C++ are very similar to the ones in C. So there's int, char, boolean, float, long, double, which you might be already familiar with C language. And coming to object-oriented features, this one is really important. So what makes C language, what makes C++ language an object-oriented programming is the OOP features. Those include abstraction, encapsulation, inheritance, and polymorphism. We are going to discuss about polymorphism and inheritance today. And yeah, we also need to understand how functions work in C++. We already had functions in last semester, so that will be really easy. And there's also function prototypes. These are the contents that I'm going to talk about today. I'm starting with the functions, then we'll discuss about the function prototypes and the function overloading and function overriding. So coming to functions are nothing but they're a piece of code which you call when you want to execute them. Take an example. Yeah. Here in the syntax, I've defined a function called CSCB, and in that CSCB function, I have a cout statement that I'm going to print whenever I call it. So this is a main function. As you know, the execution starts from main function. So whenever we run the program, the compiler searches for a main function. So here's a main function, and in our main function, we have another function called CSCB. You can name your function whatever you want. It's just a name. So we have already defined our CSCB function over here. It's void data type, void return type, sorry. So void does not return anything. It returns a null value. In case if you have a int statement, you are going to return something. So in our CSCB function, I have a cout statement, that is, I'm going to print this. So when we run this function, the program searches for a main function. Again, we have a CSCB function. We have called a CSCB function over here. So this one's going to be executed. When you run this function, you'll have this following output. So that is a function in C++. It's very much similar to that in C language. Yep. And function prototypes. If you have understood what a function is, then function prototype would be really simple. So take a look at a function earlier. We have declared a function, then we have a main function, right? If you want to declare our function below the main function, that is, if you want to declare a function like this, there's a main function, and below the main function, we want to declare our function, then we want to go to prototypes. So prototype is nothing but we can define our function below the main function. If we want to do that, then we need to do something called prototype. So if you are not doing prototype, you're simply writing a function below the main function, then you'll get a error saying that the function is out of scope. So just remember that always, always we need to write a function above main function if we are not using prototype. But if we are using, if we are declaring our function below main function, then we need to add another line. Like this is the syntax. If you look at both the programs, they are very much same, except there's an extra line over here. So in this program, this hash include IOStream and using namespace std, the header file, and we have our main function. And in our main function, I have this function 50. So I have another function. The function's name is function. I know it's a bad name, but we can give it any other name. So I'm not returning anything. It's a default void type. So void function and the return type is int x. When we run this program, here's what going to happen. The program searches for a main function. It finds a main function, and inside the main function, there's another function called function. So it comes across this function and again searches if there's a function. But we didn't declare our function above the main function, so it will throw an error. Now, if we want to declare our function below the main function, we should just add this, that is return type space function name space and data type. So if we add this line, we are free to declare our function wherever we want. We can declare it below the main function or above the main function. So we'll get the output, we'll get the desired output. That's prototyping. So we have discussed what's a function. Function is nothing but a piece of code. We call it when we want to execute. Function, a function is used to reuse a code. Like say, if you are having a very large program and you need to write a piece of code again and again and again. But using functions will make the job really easy. So functions promote reusability of code. That's our functions and function prototype. Coming to our main topic of today, function overloading. We already discussed what's a function. We use a function with its name, and in the brackets we pass some arguments. So similarly, in function overloading, if you take a look at this earlier function, if we have a function called void function. So this is just one function. If we want to have multiple functions, we can do that. We can have n number of functions. But if we want to have a function with the same name, suppose we want to declare another function called void space function. We have collisions in data structures, right? If we have two same key value pairs, then we'll get an error. We'll get a collision, and we have collision resolving techniques. But in C++, what happens is if we declare two functions of same name, we can do that. For example, take a look at this program. There's a function called print. We are declaring the function 3 times. We are having 3 functions with the same name. So this void print in bracket, we have int I, and we have another function void print. We have double, and we have the third function void print, and here it's a character type. So what's happening here is we can have multiple data, we can have multiple functions with the same name. That's operator overloading. Operator overloading allows us to have multiple functions with a single name. Here we are having the name print. You can take whatever name you want for your function. So this void print. Now we are having multiple functions with the same name. Suppose if I want to access this function, then how will I access this is by passing an integer value. If I pass an integer value, then I can access this function. If I pass a double value, then I can access this function. And if I pass a character value, I can access this one. What's happening here is if you're having multiple functions, we should have a way to access each function individually. So we can do that by using the parameters. So int I and double F and char const C is a parameters here, and that's operator overloading. I hope I was clear. So there are a couple of rules on which you can overload a function. Now since we are using functions with same name, we have a couple of rules. We can do it like this. This is a return type space function name. So again, you can use whatever function name you are comfortable with. You can even use like void csab as a function name. So take a look at this function. We have void print without any arguments. So this is one function. You can again declare a function like void print int a. So what's the difference between these two functions is we are having integer parameters over here. We can declare a third function with the same name by mentioning as float in the parameters. So this is one type. We can change the data type of the function when we are having same name. So the fourth way of doing is we can have multiple variables and multiple data types. So we can access each of these functions individually, and we can even interchange this. We can even interchange the variables inside of the parameters so that we can access them individually. That's function overloading. So we have discussed function prototype, and function overloading in C++. That that leaves us with one last topic, function overriding. So function overriding is another topic in C++. Now that we are having same function name but different parameters. What will happen if we have same function, same name, and same parameters? Suppose there's a function called void print in brackets int a. Suppose we take another function with the same name and same parameter, that is void print and int a once again. So that leads to a collision. When there's a collision, that's known as function overriding. Now there's void display, right? I have two functions named void display. So there's a function called void display and another function called void display. And in this void display, we are again having the same parameters int a, int b, int a, int b. So if you look at this, these functions are very much the same, but inside we are having two different statements. That is, I'm having like, say this is statement one and this is statement two. Now that if I want to print statement one or if I want to print statement two, how I'm going to do that? Because if you're having like different return types or different function names, I can call the function individually. But now that both of the functions are having the same name and same parameters, we can access the individual functions in a different possible way. So take a look at this program. We are having a class A and class B. This is the base class and this is the derived class. I have a statement called base class and another statement called derived class. I hope you can see the program. Yep. So we are having we are having a void display function without any parameters. So this function and this function are pretty much the same. If you want to access a function individually, then there's a small trick involved. Now what overriding means is, suppose if we want to override a function, like if we want to overwrite a function, we are having a class A and we are having a class B. Normally what happens is, if we return a function, if you return void display function, the second statement is always printed. That is, the derived class output is always printed because the first function gets overwritten. That is, this function overrides the first function. So whenever you return, the output is always the second function's return type. So In this program, we have the output as derived class statement. Now, why base class isn't printed is class A is overridden by class B. So we can take a look at a program. Yeah, we can take a look at a program. Now, in order to write a C++ program, we have various compilers. You can go for Turbo C++, you can go for Visual Studio Code, or you can even go for Code Blocks. That's as per your wish, but the simplest one of them all is this online compiler. It acts very much the same. So this is a function overriding program. Yep, this is a program to display function overriding, and we have the basics: hash include iostream and using namespace std. So this is a base class. We are defining a class base with the name base, and inside base we have a display function, and in the display function we have a cout statement. So this is one class, and in the second class we have a derived class. In the derived class we are having another display function with the same name and same parameters. Like in this function there are no parameters, that is null parameters, and we have a cout statement. We are calling this function. Now, can anyone guess what is going to be the output of this program? Can anyone guess the output of this program? So we have already discussed that enough. This is a first class and this is second class, and the output is usually the second class cout statement. So similarly in this program as well, when we try to run it, yep. So this is a derived class. Yep. So what usually happens is we can access this and access this individually by using this statement. If we have derived object, then we can access the derived class function. But if we want to access the base class function, what we need to do is we need to replace this by base. And if we run it, we can access the base class function. So that's function overriding. We have discussed function overloading as well as function overriding. Let us look at a couple of differences between overloading and overriding. So in function overloading, what we are doing is we are having a function with same names but with different parameters. Whereas in overriding, when you have a same function with same parameters, there occurs a collision. In order to resolve it, we go for function overriding. So we didn't talk about inheritance at all in function overloading, but whereas in case of function overriding, we are clearly having the inheritance. We are inheriting the base class properties to derived class. So there's inheritance involved. So that's the first difference between overloading and overriding. We are using inheritance in overriding, but not in overloading. Like function overloading can run without inheritance. And coming to the parameters, we need to change the parameters in function overloading. But in function overriding, we have seen that there are same parameters throughout the function. So there's the same function name void display and void display. And in brackets, there are same parameters, that is null parameters. And that's parameters. So we have also seen that the scope of overloading function is limited to the same function, but the overriding functions can run in different scopes. And talking about behavior and use, we have discussed that overloading, we use overloading to have the same name of functions for multiple functions. But whereas we use overriding when we have same functions with same names and same parameters. Those are the key differences. So we have discussed functions, function prototypes, function overloading, and function overriding. Functions are nothing but a block of code. We call it when we want to run it. And function prototypes, we go for function prototypes when we want to declare a function below the main function. Then we go for function prototypes, and we have just discussed overloading and overriding. So that was a presentation from my side. You can find the example programs at this link. I can share the link in chat.
Yes, you can share. Okay, no issue. Okay, thank you, Sai, for your wonderful presentation. Really,
Yes,
it
sir.
was a nice presentation. I really appreciate you.
Thank you, sir.
Yeah, exactly. Very nicely you have done given the presentation with the all the slides, and even you have explained each and every topic with a simple example. Really, I think
Yes, sir.
students, you might have cleared the concept of this particular topic, function overloading and function overriding. If anybody is having any question, you can ask him, or we will move forward to our next presentation. Okay, fine. Okay, thank you, Sai. You can
Yes, sir.
unshare your the screen and let the